First of all, good evening. I love DXing and I love contesting, and I know from looking at all your calls that all of you share the same passion that I do. I like all of ham radio, but for a long time. I've been licensed since '67, so I almost started off DXing and contesting. So it's a long time ago, but it seems like yesterday. I'm sure you feel the same way as I do. So I'll just get started here. This is a little bit of background about me. So my background is technical, but I've been a business owner. I just sold the stock in my company after running the company for 43 years. I still work there, but so I've been very busy all my life with all the things that you've been doing. And so I'm a businessman and a technical person, and my business was that sort of thing. So you get that kind of the feel of who Craig Thompson is. The other thing is when I had the means to do it, I wanted to get back into contesting, and kind of this is where this all starts. So when I first started thinking about this, it was really in the about 2008, 2009. And I have a station right here at home. I'm actually at home now. The background's at the contest station. And right behind me actually is a station. But I knew that if I wanted to get involved in serious contesting or DXing, that I needed to do something. So I started looking for land. And after talking with a lot of people all over the country, I focused principally on doing multi-2 and doing a single operator 2 radio for myself personally. So when I was designing, that's kind of the leading thing. So anytime you're going to do anything, especially with contesting, it's all about rate and multipliers. And I heard you talking about 7QP and trying to work as many stations as possible in the time that you're on, and also what are the multipliers, because multipliers make a big difference. So when you're building a contest station, those are the two principal things that are number one and number two. And of course, as a DXer, I've been chasing countries for years and years and years, except I took some time off when my daughters were in college and growing up, and a very busy time of my life. So I missed a few things during that period of time, but when I came back, I wanted to get back involved in DXing. So DXCC Challenge is actually the kind of the big thing I chase because there's really not much else to do. I've worked a lot of countries on a lot of different bands, but it's just a lot of fun to do that. And I'll do DX marathoning and that sort of thing. I'm sure I share the same interests that you do. But to get going here, when I first started this, was to build a competitive contest and DX station to be able to do multi-2, multi-1, or SO2R. I've only done multi-1 a couple of times, even though the station is quite comfortable doing that. You say, well, I assume most of you know what multi-2 is, but I'll explain it. It's 2 operators running on 2 different bands at the same time. So you could be an operator on 20 and another on 15, and then you can have partners that are interlocked. And then, so only one transmitter is actually able to transmit at the same time, and I'll explain that in a minute. But that's how you have to win if you want to design a station, is you have to be able to operate in band and very quickly. And then operator comfort, I knew from going to other places, going on DXpeditions and all the different operating, that I wanted to build a station that would be ergonomically comfortable for operators to be doing a 48-hour contest. The lighting needed to be right, heating, cooling, and everything the comforts of home, so that when you're away, you feel comfortable. So what I did a lot of station tours and research. I did a lot of analysis using VOA area, HFTA. I looked through a lot of contest results and records, and I also researched my competitor stations. I also consulted with a lot of people. There actually was I think it's KR7X or KR7X. Hank Lundberg from out your way was actually my PE that I used for the tower, the stamp on the engineering. So I don't know if you know him or not, but he's a very good guy and very helpful to me. And of course, lawyer and insurance and everything else that you need to consult when you do something like this. There's a guy that wants to be admitted. I just clicked on that. Anyhow, so from operating, then you want to assemble a team per mode. They need to be socially compatible, competitive, experienced. You have to pick contests that work for us as a team. understand the propagation for the event. I'm not telling you probably anything you don't know, and to compete both on rate and multipliers. So I actually wrote an article in NCJ about multi-two operating. I don't know if any of you have ever read it, but it really drills down on a lot of things. And if you're very interested, if you are interested in multi-two or multi-operating, actually, you might want to find that article. It's only, I wrote it maybe 3 or 4 years ago. So one of the things that I found after every contest that we do is you document any issues, you prioritize them and analyze them and then resolve them. And I do that after every contest so that there's always something to do. And these are always things that we always find that to be improved. you're going to see rate and multipliers everywhere. But the maintenance of a system like I put together is almost continuous all the time. You have to constantly be maintaining it, looking at it, and checking it out, or it leads to bad things. The other thing that when people build stations, in my case, a lot of lightning, power surges, storm damage from ice and wind and that sort of thing, that surprised me. I mean, you're not that surprised that something could happen, but to the extent that things can happen, and what you need to do to reduce the odds of them happening. So those are things I've learned. So I'm going to talk a little bit about some of the things that I've done and you can do with automation. The other thing is when I always say I discuss this with my peers and work with them on because contesters and DXers change and give advice very freely. And I'm sure I all heard you talking about that yourself just before I was here, that your peers are the most helpful. And then, of course, DXCC Challenge to me is become kind of a premier thing. When I bought the property in 2000, actually it was about 2008. In 2009, I luckily found this. It's only 5 miles from my house where I'm at right now. I found this property, and I'm going to take my mouse and put it right here. It's this one right here. And it's 20 acres right here. And you'll notice that was a cornfield. This was a horse barn and stables and a riding arena here and a bunch of garbage, literally, buildings and trees and turns out tires that have been discarded and that sort of thing for water erosion. And so then I bought it. I was lucky to get it, and then I cleared it. So you can see it all cleared off here. And right behind the building is a pile of tires that I removed from this area over here. It was 55 tons of tires that we had recycled that had been buried in the ground. So I did a lot of cleaning up, and then I put tile in the property to keep it from eroding. But I want to comment about the property. It runs north-south. Generally, it's you can see north is actually a little bit to the left of the line here, but this is a great way to buy a piece of property because then all the towers can be north-south. So when you're aimed at Europe, they're not pointing into each other. Just a thought about, and even if you put up 2 towers, you should always be thinking that way. They either need to be east-west or north-south so that they're not pointing into each other. In 2012, after we put up all this, the antennas, you can see this is the 160-meter 5-element array, and you can see the 7.5 miles of wire buried as radials underneath it. But I want you to see how the towers all line up. This is actually the so here's the 160. This is the 80-meter 4-square, and you can see the radial field underneath that. Then over here on the left, this is the stack on 40. This is the 20 stack, the 15-meter stack. And then you'll see there's the 15-meter stack. And then over here is a multiplier. It was the stepper DB42s. And right here was the VHF 10-meter stack up to 1296. And over here was a 2-meter EME array. And then this shack I had built just for but you can see I tore down all the buildings, cleaned it all off, and then built a brand new. And then how the antennas would all aim towards to the northeast at 45 degrees to Europe, or if JA, you would not be aiming, they'd be off to the side of the elements. This is what it looks like from a plane at that same period of time, so that you get a better perspective of how it looks. This is how it looks today. I'm going to talk about this, but I got a little bored during COVID time and I decided to go ahead and put up my 80-meter Yagi that I had built. And I bought a Luso tower, and that Luso tower is right where the mouse is, right there. So there's and I'll talk about that later. And then down here, I added a 6-meter EME tower because I wanted to add on DXCC challenge and add more countries on. And I also bought this farm over here, this additional 20 acres. No, well, it just became available. But this is where I put my beverages during the winter time. And I put them down in this area here because it's very easy to, and I have phased beverages both going towards Europe down here, and it's very quiet, and they're a long ways from 160. And what's interesting about that is when you do ARRL 160 or CQ 160, I can actually operate SO2R. I can listen and transmit at the same time on 160. So I can be calling CQ, have stations call me, and be looking for DX stations while I'm still transmitting on the band and get ready to jump on a DX station. You've probably seen this before, typical power levels in dBm. So when you're designing a station, and this is relevant whether you're doing field day, going on a DXpedition, doing PODA, it doesn't matter. Physics doesn't change a whole lot. So these are really important things. And if there was one thing I'd want to remember, this would be this one chart. Most receivers start overload and blocking at about 0 dBm. So if you remember, a 1500 watt amplifier is 63 dBm, and then 100 watt is 50 dBm. So how do you suppress, you need 63 dB of suppression band to band in order to not block a receiver. So it goes to how do you design your station physically with antennas or with filters in order to avoid the issues of field day. And I'm sure all of you have had those experiences with, I can't hear anything because Joe's transmitting and Joe's on another band. What do we do about it? So this is a key piece of information. This is the current. I'm going to talk about a little bit about the technology. So everything that comes in here is fed. You can see it coming through the floor. There's 8,000 feet of 1 5/8 and inch and a quarter. Most of it's 1 5/8 buried in the ground that goes to all the different towers, and they all come up through the ground, and they all go through a lightning protection, and it's all common ground. The electrical systems, everything is grounded together. And then all the antennas go through the lightning suppression, and then they go into their filters. So it goes to high power filters. There's some additional high power filters here. There's some additional high power filters here. So this is a 12x4 switch, antenna switch, which has pretty high isolation between port to port. And then behind here is a 403A Antenna Genius, which also has good port-to-port isolation. And what I'm pointing out here is the reason that all of this stuff is in one place is this is all server-based, so that all the switching is all done here. All the rotators are controlled here, and there's a server right above the switch here. There's a server. And so the only wires that you see when we go to look at the station, you're going to see the 4 drops for the 4 HF stations, and then the rest is all done on the network. So if you want to rotate an antenna, you want to switch antennas, you want to combine antennas, you want to change anything, it's all done on the network. And so I highly recommend any way you could automate your station. Those are stepper controllers. And again, I use software, TST Rotator AZ. Server based, so that they all run through the server, and then every station is a client. So a weather station, there's a triplexer. This triplexer feeds. This is a which first this goes out and it goes to the 1 5/8 that's out here to go to the Luso tower, but it has a triplexer because on there is a 10 and a 15 and an 80-meter Yagi, and the triplexer combines it on an 1 5/8. And then on the other end, it's split again to the antennas. This is what the station looked like from 2011 to 2016. You see, I used Alpha 87As, auto-tune amplifiers, and you can see the filters here. And then notice the monitors, the Elecraft, all of that sort of thing. All good radios. This is what the wiring looked like. And you can see it's a very busy behind every radio. I'm sure you're all familiar with that because you probably all have similar radio setups. But I just point that out. There's UPSs up here. The amplifier, I had ferrite chokes on the 87As. This is an iterative when I switched from Elecraft to the Flex radio. So that was 2016. So 2016, that's when they came out with the Maestros. And I wanted that interface with the knobs right by the keyboards so that I could operate SO2R or have an interface. And actually the interface is very similar to an Elecraft radio, except it has a pan adapter. So these are, those would be like 6700s, 6500s, that sort of thing that are sitting there. So, and then you can see still the alpha, that's an SPE because I DX at this particular location and I want an instant on amp when I'm Jason DX, just like you do. You don't want to wait for tubes to warm up. So this is what it looks like today. And you can see here's 4 operators. Each one of the guys that are in the middle are run 1 and run 2 operators, and their partners are off to their side. So each person on the outside is a partner, and every one of their radios, every one of their screens looks the same. So they can sit down at any particular location and they have the same. But you'll notice I'm using a PGXL with a TGXL on top, which are flex. And then there's a filter set here for the 100 watt level from the in between the radio and the amplifier. And the amplifier, you'll notice there's only one amplifier because the radios are interlocked and it switches as fast as the radios can go back and forth. So there's only one amp. Then I have UPSs on each radio, and if we ever have an outage, everything is kept up. And then I have a generator that lasts longer, like 2 or 3 minutes. The generator comes on, and then we get full power back. The amplifiers drop off. This is actually the old screens. So this is a Flex Radio SO2R, and this is actually, I just want you to see how busy it is. This is SO2R with a RTTY. So you'll notice I have the DI windows. So on each side, this is one side of the radio, and this is the other radio. This is two-tone up here, and this is MMTTY down here, and the same over here. And so you could just take your mouse and go back and forth and right-click. It enters the call. In other words, you could take left-click, enter the call, right-click, send, and then just scroll back and forth with your mouse as fast as you can operate and be on 2 bands at once as one operator. So here's a setup. I just showed this so you can see the whole thing. This is when I'm operating by myself. You can see I have the online scoreboard sitting right next to me, so I can see how my competitors are doing. That's a SAL 30 controller, and I actually have that set up now so it's networked using PST Rotator AZ. This is what the new screens look like that I just employed about 3 years ago. And look at I love the real estate and you can see I'm using WSJTX, and it's FT8, and I'm operating the ARRL digital contest. And I actually operate SO2R. So the left side is 1 band. You can see it says 15 meters. And on the right side, it's 20 meters. And as the timing of the 15 seconds goes by on one side, then it flips and the other side transmits. And I'm running low power. It's only running 100 watts. You can see the amplifier up here is in standby. But I just note, here's all of the antennas and all the rotators right here. And every little green dot right there is an antenna. So if it's a stack of 3 15 element, on 15 meters, there's a stack of 7 over 7 over 7. I'm using the top 2 right now. And up here it says 20 meters. So it's a 6 over 6 over 6. And I'm using the top 2. And you can see where they're rotated. But the amplifier is off. I'm operating low power. So here's SO2R now. Use it for RTTY. And I tell you, when you do a RTTY contest, there's a lot of RTTY operators. And now that the activity's all gone away, all digital is really on FT8. But one of the things I want you to notice is how clean and easy it is. This is actually SO2R for CW. And you can see, I want you to see, here's all the antenna selection. This is all green heron. And of course, the software is free. It's just a matter you got to have the devices to talk to it. So that this where I got my mouse right now is actually that 12x4 switch. So the B side, this is a Flex 6600. So you got an A and B slice. So you can see on the Maestro A slice is 80 meters, and down here is 20 meters, the lower slice. And you can see what bands are being selected up here are it's all automatically done. The filters are automatically selected. The band is automatically selected on each side. You can see those say 80 meters. And then I have ways, though the other indicators are combinations of antennas I might use on that band. I'm in the middle of the United States, and sometimes it's just difficult to, if you're just working Europe, you're working Europe, that's easy. But if you're doing a stateside contest, you might be open to the Northeast and the West Coast at the same time. And so you have to have two antennas. So, but you can see how it's easily set up. This is actually CW. This is SO2R cabling. And this was a lot simpler. You can see the A and B come right from the filters. An antenna that I added, one of the first things I realized after I built the station was I needed an antenna that wasn't as sharp as the antennas I was using on domestic contests for QSO parties, NAQP, sweepstakes. So at home, I had a Monster, the original stepper Monster. So I decided to bring over the 589. That's a US tower crank up that goes up to 89 feet. And that's a Monster. And then that's a 5-element on 6 meters there. Right, currently, I have a 7-element on 10 meters up there. And my daughter lives in this house, by the way, just to explain that. But you can get a perspective of what the shack looks like. And when the guys are over, we always have this is a drone picture, by the way. And you can see there's a grill there and a couple of chairs. And when we contest, we always have guys bring food and grill out, and we have a good time. So I wanted to talk a little bit about the automation. I'm going to pick up speed here. So I use client server, Green Heron everywhere. Each station's a client. And then you obviously have to have antenna lockout when you're switching, but it's all automated, except the partner stations can manually take an antenna and say, I want to go to South America, and they'll take the Monster and it'll be aimed, because that antenna goes through South, and they'll aim it at South America, they'll aim at New Zealand or something at the same time and very quickly. And I use PST Rotator AZ, which is software that actually will control stepper antennas. It'll control rotators. It actually does a lot of different things. So this is the SO2R screen, which I was showing you before. And like when we're doing a QSO party, you can see all the counties over here. This actually may be 7QP. I could be wrong. Yeah, it might be. I can't read that small. But anyhow, this is a close-up of what it really looks like. So here's all like 10 meters. And you can just click on a green, and you can say, I want the upper two, or I want the bottom two, or I only want one. And you can actually click through the antennas and hear the station get stronger or weaker depending on their arrival angle. You can see I just have one. For instance, I'm working maybe Caribbean. I'm using the 20-meter lower antenna, and it's aimed at 136 degrees. So here's what the filters and antennas look like. This is by the way, that 47 at the top is a signal strength between the transmitter and the receiver in the Green Heron complex. This is actually PST Rotator AZ, and this is tracking the stepper right from the radio. It just tracks it, and you can use it with any radio. And then the stepper automatically tunes as a client, so that if your partner wants the stepper, he can track it and do the same. So I just briefly go over this. I have a computer network like you do in your shack, and we have I do isolation between the ham radio part and the security and the fun part. Everybody shows up with a handheld or a laptop, and they want to get on. Well, I isolate them from the traffic of the ham radio activity. So this is actually all of the things that would connect by USB and then USB to COM ports, and they appear on the server as a COM port when you're actually selecting them for programming with the Green Heron software. And of course, you've seen this before. So you have the computers and the wireless router, And then you have all of this other stuff, including the PGXLs, TGXLs. So there's a lot of traffic on the network. The other thing that actually I had suggested a long time ago to Stepper, and they actually created it. I'm not sure if this was Visalia or Dayton, but they said, "Here, Craig, we made something for you." And they came up with a wireless link. I think it's RS422 using Green Heron, and they were able to eliminate the wiring between the controller and to the remote board at the base of the tower. And that's pretty cool because it eliminated, every time I got hit by lightning, it would, or even a lightning strike, it would take out that USB or that the little chip that's on the inside, that's on that 4 wires that they use on either end. So anyhow, I talked about this. You want to have skilled operators, know how to manage pileups. Everybody likes different modes. Work partnering with skills, interleaving, super check knowledge, which means that they're active contesters, so they know who's active and not, so that they can pick out calls real quick. So you know all those people yourself. You know, somebody prefers RTTY or they prefer sideband or CW. The other thing is team skills are something that have to be developed because most people do not operate as a team. But it's just like watching a basketball game. The more they play together, the better they get. So I always try to invite back people every year to the same contests, and they get better and better at it. So I alluded to this in the last couple of years. I decided to embark on a project. So I had an 80-meter Yagi from before that I put up, and it was actually too big for the tower, so I took it down. And then I said, what else can I do with it? So I added an interlaced 12. This is a JK antenna. He created a long boom Yagi for 12 and 17, because what I decided to do was I wanted to improve myself on those bands. And then the same, I also wanted to add, what I wanted to do was improve in band. And so what this actually led to was I took down my 2 DB42s, which are stepper antennas, because I was using them on in-band, but they were actually too close to other antennas that the in-band wasn't as good. So I was trying to physically isolate the antennas more to be more competitive, to get more QSOs on a band, in-band. So I could talk to K3LR because I was using his design on OWA antennas, him and WA3FET, I think it is, and maybe somebody else. But anyhow, WAWV and Tim redesigned the OWA antennas and shared with me that I actually bought all the hardware from DX Engineering, did all the work, made the antennas. I got the biggest kick out of doing that. So I have kind of the next iteration of 10 and 15 meter OWAs on the Luso. So I'll just show you briefly. This was the original antenna. It was above the 15 meter stack. I used what's called tornado tuners, and you can see the matching circuit there and the choke. And this is what it looked like when it was constructed. There's the loading coil on each element. So it's 59-foot boom, 4.5-inch center to 4-inch extensions. The reflector is 84 feet. It's actually, that's the original design. It's probably closer to 90 feet right now. I extended the reflectors. Driven is 82.3, 7511 hairpin match. They made, these are special tornado tuner, tornado coils, and other people are using, by the way, you can buy them from JK. And of course, the Green Heron with wireless remote cards. Each element is individually tuned. Yagi's tuned for maximum gain, preset created for each band segment. You can read. Anyhow, it weighs 650 pounds. And actually, Ken made a special, because the boom and the mast at the top of the Luso are both 4.5 inches. He created special clamps like this, the ones you'd get from DX Engineering that go around a 3-inch or 2-inch pipe. You know, they 360-degree clamping. And he did that. So I got like 6 above and 6 horizontal, and he did that. And the antenna so far, knock on wood, has withstood some very strong winds and not moved at all. And then this is the actual design. This is what JK designed for me on the 12 and 17. He calls it JK 1217 Mega. Very nice antennas. They work really well. And then this is the new design. And this actually, the guy that owns DX Engineering is NOAD. And this is where they actually went up first. And I know that Tim in the last 2 years has changed all of his Yagis to these. So then these are VA6AM triplexers. I talked about them earlier, and they're just excellent. Real quickly, I have to have a building permit to do all of this. And I don't want to spend a lot of time on this, but it's never been easy to do anything. And long story short, be prepared whenever you do a project or make a change to have to fight City Hall. And you will win, but you have to be very persistent, and you might have to spend some money, but it's always worth it at the end. So what I did is, you saw the layout before, and you saw where the Luso. So this is the building permit, and you can see at the same time I said, if I'm going to get a building permit, I'm going to get one for the EME array at the same time for 6 meters. So I thought I could actually work some stations on 6 meters off the moon that I can't work using normal E or rare F2 propagation. So anyhow, I did a permit that. I had to have hearings. I went through a bunch of crap. They gave me a very tough way to go. And I had to have soil samples. By the way, the first time I did everything was, I don't know if I'd say it's worse than this, but every time I've been through it, it's been a process. So if you ever are looking for a tower engineering company to stamp your prints, write that down. Tower engineering professionals, they've got a stamp in every state. And this is who Roan Tower uses. And so I had to have the Luso Tower stamped by an Illinois structural engineer in order to get permission to go ahead with my project. So you have to do structural analysis. So they reverse engineered the entire Luso Tower. It was like 400 pages long, and we submitted. I know they didn't even look at it. All they looked for was a stamp. But there's the stamp you can see right down here. Licensed structural engineer. Yay. State of Illinois. So anyhow, we did all this work. This is what the Luso looks like. And my intent was to put the 80 up here. At the C level right here is a 15-meter Yagi. The D level right here is a 1217. At the E level was a 10. This is 40 foot high, and it fits in a container. I'll show it to you in a minute. So anyhow, here's a building permit. This is the base. I don't know if you've seen a Luso Tower before, but if you look at the drill, you can get an idea of the magnitude of the thing. It's crazy. So these are the things I had to do. I had to think about everything. I wanted an 1 5/8, use a triplexer, and I had to have power cable out there. It had to be 240 volts, of course. Weatherproof cabinet, switching between triplexer, just things that I had to think about. Yeah. And initially I thought I had to have 2 cranes, but when they shipped it, they shipped it in a container that has an open top. And I'll show it to you in a minute. This is actually where we're digging the hole. This is where we did the soil sample. And they started digging. I'm going to just show it to you. This actually gives you a perspective with the rest of the other towers on the property and how we're digging it. And of course, it has to be very flat. It has to be perfect. So we were being very careful. It's 8.5 feet deep there. And then you have to put in the lightning protection system here. So we had to drill down. We could see where the water table was. Initially, when I did this, the water table was only a foot down. So I was so thankful that we did this in August when it was dry season, so that you can see where the water table is. You can see putting in a lightning protection at the base of the tower and marking it off. And of course, it had to be within a 1/16 of an inch of being flat. And you can see why. So I want you guys to take a look at the little comedy here. So the New Holland is holding the little Kubota from tipping over. Well, it's lowering the base into the ground. And here we are getting everything leveled. And then we had a guy come in and weld the straps to the lightning protection. I had a crew of structural guys come in, do all of the rebar work. These guys were really amazing guys. That's what they do. I called the Union Hall, asked them if they could come out and do this, and they were there, Johnny on the spot, and in one day did all this work. It was incredible. Then they brought in and started pumping. They brought in a pump, and we had to use a pump. You couldn't just dump cement in there, because if anything had hit that tower, it would have taken it out of level. You wouldn't have been able to remedy it. So we controlled it. You'll see over here, Peoria Building. This is the inspector. He wanted to see this, so he came out here. He was there right when the first truck pulled up, And then this is the guy that's taking his remote control and actually controlling the cement fill. This is actually Andre, who's an expert at installing Luso towers, and he came and made sure that we were doing everything exactly. And you notice we put plastic all the way around this to keep anything from no cement to be dropped on the top of that, so it was very, very flat because you can't get it off. So here we are, pouring, pouring, and you can see all the trucks backed up. See the trucks backed up there? There's actually 2 cement trucks on the back of that truck, and then there's 2 more. We ended up with 7 trucks and about 110 cubic yards of concrete. And then it had to be smooth so the water would drain away. And you had to leave a gap below this because that's where the wires go. So then at the same time, I told you I put up an EME Roan 65. And of course, I take a look at the shack. There's the grill, the chairs, you know, the normal stuff. This is actually when the truck arrived, and had to have a crane there to get it out. You can see what it looks like. We removed the top. You can see how they packed it all up. And by the way, there's a lot of stories I could tell you about. I'm just going to go through this very quickly. You can watch how that's a weight. That's 10,000 pounds. There's 2 of them. That's the rotator at the base. And I like their marketing. I think that was pretty cool. Then this is the that tower all laid out ready, and now the concrete is actually curing, and so we had to wait 30 days. And then they showed up. And if you've ever been to Dayton or anywhere where Luso exhibiting, this lady is always there, and she calls herself Luso Ma. And she acts like she doesn't understand you or anything, but she's a very, very smart engineer. And she works in sales, and you see her. She actually lives in Tokyo, but she's from China, and they make the antenna or the tower in China. And she was the plant manager, so she's an engineer. But now she's living in Tokyo, and she's the salesperson for her. And believe it or not, no one has ever bought a Luso tower in China. They make them there, but they don't buy them there. So here's the crane back, setting it in place, and then setting the weights. And I brought a JLG to make sure that we could easily get to things and get to the straps. But that's the rotator. And there's that little sending unit right there where my mouse is actually what connects to the Green Heron RT21 to tell it where it is, what direction it is. Because this tower will keep operating 360 degrees forever. So you got to have some way of communicating with it. These are the control systems, a little controller here. The gear that rotates it. This is actually the lift in the vertical part, the raising of the tower, lowering of the tower. This is the motor and the gears for that, but it's counterbalanced with those weights. And you have to know the weight of the antenna. So here's the antennas I made. These are the OWAs, the 10 and the 15. This is the 80-meter Yagi, all out there in tune, tested, I mean. And then so then after everybody left, then we put up all the antennas. So I called in another company that's all they do, is a company called TowerWorks, and they helped get all this stuff mounted up here for me. And that's what it looks like when it's up. I'll do some quick pictures here. So here's actually, I'm going to play a little video. This shows you the tornado tuner. And I show you this so that you can understand. And this tunes each element. So what's really cool about this, I have 3 of these all synchronized and tuned to the reflector, the director, and the derivative of that 80-meter Yagi. And they're stacked out there at the base of the tower in a box. And then I wirelessly control them from a station that I'm sitting at. So if I say I want it, it'll go anywhere from 3,500 to 3,850. 1-to-1 SWR, bandwidth of 50 kilohertz in every segment. Isn't that cool? So this is what they look like. So these bottom 3 right here are in fact those they control those motors. And then this one up here controls the rotator of the tower. And up here you can see the triplexer, power supply, UPS, And this is the switch control for the antennas. And of course, grounding, and there's the inch and 5/8 to the right of it. So here I am at the top of, I'm at about 140 feet here at a DB42, looking north generally, and you can see the Foursquare, and you can also see the Luso Tower. This is what it looks like when you drive from the north to the station, and you can, as the towers get closer, and I have the antenna up so you can see what it looks like, get a perspective of it. And that basket is interesting. That's where the cables go up and down. There's a couple of things that I learned about. This is not the best. The wind has to be fairly low for you raising and lowering the towers, because the cables go at different speeds and they can't stick to each other, and they will. Those are RG8 cables, and they only come from the triplexer up to this point. So the longest is 150 feet. But my point is that they have to drop in the basket. And you might find, if it's windy or something like that, or it's icy or something, something that's not good, that you might have to climb up there and make sure the cables are coming down or not going out. I may move that basket down the tower where I can actually get to it easier. That's the antenna rotating. What I like about it is it ramps up and ramps down, and you'll notice the 80-meter Yagi, which is quite large, doesn't really wiggle around a lot. Normally, if you just take a regular rotator, you'll get quite a bit of movement. There, you can see it move a little bit. There it comes back. Not bad, huh? So I had another problem. This all occurred at the same time, and I'm going to briefly show you this, but the 80-meter Foursquare, I'd used Roan HBX 64 before when I built it. It's actually the same setup that a lot of guys have done. And they had evidently met the time of the insulator had expired, and with the wind and ice that I had, they were blowing over. So I talked to K3LR, and he had actually replaced all his, and of course he didn't tell anybody, but he told me after I said what problem I had, and he told me I should go to the Universal Towers, and I did. So what I did, you can see I'm all laying out there, and I had to, this is what they come with, but of course we can't use that. I had to come up with insulators. So we created a new T. You can see underneath, I had a friend of mine cut all these T's, and these fit on the HBX 64 bases. And then this is, that's out of sequence. This is actually the new insulators that I had made. JK made those for me. And then as I would raise them in the air, and then we welded them so that they would so they were perfectly flat and square and solid. So you can see the lightning protection. I also sealed, you can't see the seal because it's not on in these, but I sealed every one of those fiberglass, or not, I mean insulators, not fiberglass, but insulators. They're very strong. They're stronger than the aluminum. And what I felt is that the insulator, what had happened over the years is water had seeped in, and when it would ice up, it would fracture it and weaken it. So this time I sealed the very top of it so that can't happen again. So this is how pretty they look. And one day there was a double rainbow, and I raced out there, and I thought that would be a cover for QST. Got an 80-meter Foursquare with rainbows. The DB42s, I'd had them since I put them up. Since I built the station, and you'll notice above it I have a couple of VHF antennas. But I decided that at the age of 72 that I was tired of fixing them all the time. In 1 year, this past year, or the year before last, I was going to take them down and I was going to redo them. And I said, you know what? If they last another 10 years, I'll be 82 and I don't want to mess with it. So I said, what can I do instead? So I took them down and I put up the top antenna is a JK 40-meter antenna. It's 4 elements. And then the antenna down below is a JK 20-meter antenna. And of course, all of the problems and every mechanical issues of the other antenna, those antennas are really good antennas. I don't want to say anything derogatory, but at my age, climbing up there and maintaining them, or having to get cranes all the time to service them and work on them. I just said enough I've had enough of that. But the value of having a DB42 is excellent, but it's a very sophisticated antenna, a lot of things. So I had a couple of friends, AA7A and KY7M, that had a 6-meter array, and I wanted to copy that. I saw this picture and I says, I want to do that. So I designed, mechanically picked out what I was going to do with a freestanding tower. I checked out the Innoventenna 7-element LFA WAZ, which you probably have yourself, and actually set one up for a year and experimented with it. And then I created this, and I had my my draftsman at my company make this drawing, so we had it for submission because we had to have a PE stamp for that. So anyhow, here I am complete with this. This is actually aimed at the moon. I was actually copying a station off the moon, and then it was winter time, so I haven't used it. It's been roped in place ever since, and I haven't had time actually to do any moon bounce with it, but I will be getting to it. Anyhow, I wanted to tell you all the work that we've done. This is we received in 2023, last year, #1 world, #1 North America, #1 United States, and multi-operator two transmit. I've never won #1 world anything. So I wanted you to see we got something for all of the work after all these years. And that was the team that did that. And I'm very proud of everybody that ever comes there and operates, but that was a really feather in our cap.